Hello everyone! In this video we're going to do two example programs that have pass-by-reference functions. One of them simulates an ATM and the other simulates a round of blackjack. We'll do the ATM one first. We're going to demonstrate both pass-by-value and pass-by-reference functions. Remember, pass-by-reference functions are identified by having references in their parameter list. So each of these values, marked with an asterisk, are pointers, and pointers are references. So these three functions are pass-by-reference functions, which means any changes we make to account balance within the function are going to be evident everywhere in the program. We're going to change those values at the memory level. But to get started, we're going to build a simple pass-by-value function. This one doesn't take any parameters. It's our menu function. And remember, all we want to do with the menu is print out the options for the user. This is an ATM, so we're going to have some of the basic options, probably not all of them, where they can withdraw some cash from their account. They can deposit money into their account. Or a lot of ATMs have this fast cash option, which distributes a certain amount of cash if it's in the account. And some of them are 60 and some of them are 80, it just depends on the bank. They can also view their account balance, and when they're done, they can quit. They can leave the ATM. So the only purpose of the menu function is to print this menu for the user to see. So there are no preconditions, and the only post condition is that the menu is printed. So in main, we're going to have the user's response to the menu. So what we'll do is we'll use the menu to prompt the user and read their response into this variable that we've built for that purpose. And as long as that response is not quit, then we want to process it. And before we exit the while loop, we want to be able to prompt them again. So we'll do a quick little test where we print out what the user chose and make sure that the while loop is correctly running as long as they don't enter quit, and that we're correctly getting a response after prompting the user with the menu. And remember, this is just a part of good programming practice. We're going to build a small piece of the program and then we're going to test it before we move on. So here's the initial printing of the menu. There's all of our options. So we can choose any of these values. And as long as we don't choose quit, it keeps going. But when we do choose quit, that's when it leaves the program. So our menu is working the way that we expect it to. We'll print out a little welcome message. And then after they give us their response, we'll put in a new line, and that'll just help with keeping all of our output from getting crowded together. So now we're ready to build in our other options. All of our other options require us to have some starting balance. So we're going to ask the user for their starting balance. Of course, normally if we built a real ATM, we would get that information from their account. We would get their account number from their card. But since this is just a simulation, we're just going to go ahead and ask them for it. We're also building a program that only uses integers. And of course, we know that our account balance usually has change, like an extra 57 cents or something similar. But in this case, we're only going to deal with integers. So we're going to ask them for their starting balance, and they will provide that for us, and we'll store that value in account. Then we'll ask them what they would like to do, and based on that choice, we'll pick one of these options. So let's do the easiest one. That's the view balance. The only value it takes in is the account balance. And all it does is prints this out for the user. So all we're going to do here is print out their current account balance. So in our main function, we'll start building something to process these choices. If they choose 1, 1 corresponds to a withdraw. So we would call the withdraw function. Option 2 corresponds to deposit. So we'll call the deposit function. Case 3 corresponds to fast cash. So we'll call the fast cash function. Case 4 is the printing the account balance. So we can call our balance function using the account number. And we'll test this one. Since that's the function that we've already built, we'll check it to make sure that it's working. Option 5 is quit, but if they've selected quit, we would not be in the while loop. So we're going to say that anything that's not 1 through 4 is not a valid option. And then we'll print the menu again. So that they can pick a new option. So if we run the program again, we'll see all of our new additions, our welcome message. What is your starting balance? We'll give it some starting value. So we can now, here's the menu, we can withdraw, deposit, fast cash, view balance, or quit. So if we put something that's not valid, we'll get sorry, that's not valid. The only function at the moment that we have implemented is view balance. So if we do that, it'll print our balance and then goes back to the menu. And if we quit, then it will quit. So now we're ready to implement a new function. We can pick from these 3 that we haven't yet done. So let's do withdraw first. And what we take in as a parameter is a pointer to the account balance. And what we're going to do in the function is ask the user how much they want to withdraw. Check to see if they have that much money. And withdraw that amount if they have enough. And by withdraw, we're going to have to update the account balance. we'll ask them how much they'd like to withdraw and read that amount into this amount integer that we've built. And if that's more than they have, then we're not going to let them withdraw that amount. So we need to compare the amount they gave us to the amount in their account. So we need to go to where account balance is pointing in order to check that value. If we compare it to the contents of this variable, we're going to get a memory address. So instead, we want to compare it to what account balance is pointing at. If they don't have enough money, we want to let them know that they don't have that much in their account. And we want to make sure we don't modify their account balance in that case. But if they do have enough, we can go to where account balance is pointing and subtract the amount that they want to withdraw. Because if they're withdrawing, they're taking money out of the account. The balance will go down. And then we can return. And since we're using a pointer to account balance, we'll know that the user's account balance has been correctly updated in main as well as here. So to call the function, we're going to come up here to withdraw. We'll call our withdraw function and pass as a parameter the address of account. So that when we go into withdraw, we have a pointer for account balance that points to the account in main. So let's test this function. We'll again give it some arbitrary starting balance. And if we want to withdraw more than we have, all it says is you don't have that much in your account, so you can't withdraw that amount. We can view it because we know we've fixed that function. Let's try a withdraw that will work. Say we only need $400. We'll have withdrawn it, and now if we go to view our balance, we should see an updated balance with the money we withdrew taken out of it. So now we're ready to build one more function. We've got two more to do. We'll build a deposit function. Deposit will actually be a little easier than withdraw because there's no checks to make. We're just adding money to the account. So remember, account balance is a pointer to the user's account. We're going to ask the user how much they want to deposit and add that amount to the user's account. So we'll ask them, how much do you want to deposit? We'll read in that value into amount, and then we will update account balance with that amount. And then we'll return to the main function. I'm adding in these new lines just to keep everything from getting too condensed in our output. And remember, this is a shorthand that we can use with all of our arithmetic operators. So go to where account balance is pointing and make that equal to what account balance is pointing at plus amount. So now in order to test the function, we need to modify main so that when we call the deposit function, same as withdraw, we give it the address of the account from main so that it has access to the memory location of account. We'll test it using the same initial starting value. When we deposit, it says how much do you want to deposit. We'll put some money in the account. When we view it, we should have the updated value now. And if we want to withdraw, we can still do that. And our value is updating with each new transaction, so everything appears to be working the way that it should be. So let's build our last function. This is our fastCast function. We're going to pick an arbitrary number to be our fastCash value. We'll pick 60. Same precondition as the others. Account balance is a pointer to the user's account. We're going to first check to see if they have that much. So we'll check to see if they have $60. And if they do, withdraw that amount, and if they don't do anything. So we're going to go ahead and make this a constant value that we can use, so that if we want to modify our ATM later to make fastCash 80 or even 100, then we could just do that in one location. So if they don't have enough in their account, we'll do the same as the withdraw function. Sorry, you don't have that much. But if they do have that much, then we'll go to where account balance is pointing and subtract out that fast amount. And return back to main. So now we're ready to check this one. Remember, we'll pass it the address of the account. And now we should have a fully functioning simulation of an ATM. So I'll add a little message onto the end. That'll be for the ending. If they select option 5, just check everything. So let's say that we're starting with 100. If we withdraw 50, we should have 50 left, which means if we try to do fastCash, we shouldn't have enough money. But if we deposit that 50 back and then do fastCash, there's no message printed here, which we could fix, but currently there's no message associated with fastCash. Instead, it just gives us the cash and updates the account. So now at the end it says thank you for using our ATM before it quits, and we have now a completed example. Our other example simulates a round of blackjack. We've gone ahead and written some function prototypes to get us started. We're going to be able to get a card, print the winner, get the next turn, and also process a turn. So in here we have a combination of pass by value and pass by reference functions. Remember, the pass by reference functions can be identified by having references in the parameter list. So this is the only one that has a pointer or reference. So this one is going to be a pass by reference function, meaning it can modify player score at the memory level. But these other two do not have pointers in them. They do not have references. So these are pass by value functions, which means we can't change score 1 and score 2 inside print winner. And we won't be able to change player or score inside get next turn. So we'll build each of these functions, and we'll use main to test them out. We're going to be randomly generating cards, which means we're going to need to seed a pseudo-random number generator. So we'll go ahead and do that to start with. That way in get card, we'll already have the pseudo-random number generated seeded, which means we can use that to develop a card. So there are no parameters, so There are no preconditions except that we're assuming the random number generator is already seeded. And our post conditions is we're going to return the value of a card. So possible card value for blackjack range from 1 to 10, where all of the face value cards are worth 10 points. For the ease of our example, we're going to assume that all aces are 1, even though that's not how blackjack's actually played. So we're going to generate a random number that represents a card. So aces are 1s, jacks are 11s, queens are 12s, and kings are 13. So we're going to generate a pseudo-random value. We're going to constrain it to 13 possible values. And we're going to make those values be between 1 and 13. And if the number we generate is higher than 10, we're going to set it equal to 10. And this is because the value of the cards for face cards is still 10. So even though Jack, Queen, and King have different card representations, they all have the same value, which is 10. Then we're going to return that value. So in main, in order to test it, we'll build something called current card. And we'll let that call get card so we can print out the value and check to make sure we get some pseudo-random numbers and that all the values that we get are between 1 and 10, because all of our values are from 1 to 10. Okay, so we got a 5, we got a 2, we got a 10. We don't know if that's a 10, Jack, King, or Queen, but we know the value is 10. We got another 5. Okay, so we can assume that get card is doing its job. And we can move on to a different function. Let's go ahead and do print winner, because print winner is a relatively easy function for us to build. Its whole job is to print who won. We're going to assume that these scores correspond to their player number. And based on their score value, we'll print out who is the winner. So there's a couple of things for us to consider. Player 1 wins if their score is higher than player 2, and player 1 hasn't busted. So that's what it's called if you go over 21 points. It's called busting. So we're going to check both of those conditions. If score 1 is higher than score 2, but score 1 is not greater than 21, so as long as it's still less than or equal to 21, then player 1 is the winner. Otherwise, it might be player 2. If they have a higher score and they didn't bust, then they're going to win. It's possible in our simulation for them to have a tie, because we're not going to be looking at the suits of the cards, which is how you would break ties. If they have the same score and they both didn't bust, then there can be a tie. So this covers all of the non-busted scores. So now we need to cover the other side. Player 1 busts, but player 2 doesn't, then player 2 is going to win. So if one player busted and one didn't, player 2 is going to win. And we can include why. We have the opposite possibility where player 2 busted, but player 1 did not. And we have a final, not very common possibility, which is that both players bust. And that will be our final default statement, which is technically a tie since neither should win. But since it's a bust, we'll say no one wins. And so that's all that we're going to be doing in this particular function, is printing out who's the winner based on these two scores. So when we test it, we can test it just by calling it with several different possibilities. So if player 1 has 20 and player 2 has 15, we expect to see that player 1 is the winner. So we're just going to make sure that we get the output that we expect based on a bunch of different test cases. And remember, this is called white box testing. We know how the code is constructed, so we're going to build test cases to utilize each of those different else, if branches. Well, I'll check the tie scores. And if they both bust, no one wins. Okay, so we've exercised all of the possibilities for print winner, so that is working the way that we think it should, and we can move on to the next function. So getNextTurn is going to determine if the user wants another card. So they can get their next card if they want, or they can choose to stay where they currently are. So we're going to take in the player number. So this is the player number. And score is their current card value, the sum of all of the cards that they currently have. So we're going to ask the user if they want another card and return their response. So we're going to have an answer variable. We're going to show the user their current score with their player number. We'll say your current score is whatever their current score is. This will be player and score. And ask, do you want another card? We'll let them know what we're looking for. Yes is 1 and no is 0. So we're relying on an integer value. So we're going to scan that into answer. And if that is not a valid value, we're going to ask them again. So it's got to be either 0 or 1. So if it's less than 0 or greater than 1, or greater than or equal to 2, then it must not be the right answer. We'll let them know that's an invalid response and prompt them again. And we'll keep doing that as long as they give us an invalid answer. Once we have a valid answer, we're able to return that. So this is another function that we can easily test in main just by passing in some arbitrary scores. And we'll have some place to store it even though we aren't going to use it in main. Okay, so if we enter something that's not valid, it should say that's not valid, do you want another card? And when we enter a valid response, it should quit, whether that's 0 or 1. Okay, so that's 3 of our functions. Now we've got one more, which is going to process a user's turn. It's called doTurn. And we take in as a parameter the user's score. So pScore is a pointer to the user's score. And we'll assume that if we're calling doTurn, then they have asked for another card. So we will give them another card. So first, we'll call the getCard function so we can get a new card. And we'll show that to the user. Tell them what value we're adding to their score from current card, and then update their score. So we're going to go to where player score is pointing and add to it the current card value. And let them know that their current score has gone up to whatever the new value is stored in player score. So just like when we're accessing a pointer, if we want to print out the content, we want to print what the pointer is pointing to. So we're going to dereference the pointer with the asterisk so that we're printing the value it points to and not the value it stores. Remember, the value it stores is a memory address. So if we print it without the asterisk, we're going to see that actual memory address. Instead, we want to print what player score is pointing at. And then we're ready to return. So we're going to test this one out. We're ready to start building some scores into our program. So we'll have scores for both players that will start at 0. And then we'll also include a mechanism for players to say that they are done or not. And so we're going to be using some flags for that. And remember, 0 represents false, so we're starting out assuming that they are not done. That done is false. Now the game starts with both players getting 2 cards. So player 1 is going to have 2 cards added to his score. And player 2 is going to get the same thing. So each player starts with 2 cards. And as long as both players are continuing, as long as either one is getting new cards, then we want to keep going. So if either player is not done, we're going to let the game continue. We're going to check a couple of different things. First, if player 1 is still drawing cards, then we want to allow them to draw some cards. So if player 1 is not done, then we're going to ask them if they would like another card using our getNextTurn function with player 1's number and player 1's score. And so remember, getNextTurn returns a value that's either 0 or 1. So if they want to get a new card, this will be a 1 for true. And if they don't want a new card, it'll be 0 for false. If they do want a new card, then we're going to call doTurn, which will give them a new card, and update their score. Now doTurn is our pass by reference function, so we need to pass it the address of score 1 so it can be updated. Now otherwise, they don't want a new card, which means they're done, and we're going to change done to true. We're also going to check to see if they drew too many cards, which means they busted. So if they drew so many cards that they now have a score higher than 21, then they've busted, and we should also say that they're done. So now we're going to do the same thing for player 2. Player 2 is allowed to draw cards. So if they're not done, we'll ask them if they would like to draw a new card by passing their player number and their score to getNextTurn. And if they would like another card, then we will call doTurn with their score. If they don't want another card, then they must be done. And if they draw so many cards that they went over 21, then they're also done in that case. So we'll continue running the loop until both players are done drawing cards. And after all players are done drawing cards, we can print who the winner is by sending score 1 and score 2 to our print winner function. So now that we've got our main put together to utilize our functions, we'll test it and see how it goes. Player 1's current score is 17, which is pretty good, so we're going to stop there. But player 2's is better, so they're not going to draw any cards, and then they'll win. Let's go again. At 16, let's say we do want to draw a card. We drew a card and the value is 9, which means we're now over 21, and we've busted, which means player 2 doesn't have to do anything in order to win. And that's it for our second example, which demonstrates a round of blackjack. In our next video, we'll do some examples of functions that have arrays as parameters so that we can see how arrays as references are affected by functions. I'll see you then.